Hello, Heritage Academy geometry students, and welcome to another outstanding geometry adventure in seeing, doing, understanding. This is lesson 2.6, that is chapter 2, lesson 6. And as always, this video lecture is brought to you by me, Mrs. Elzagary, PowerPoint, and the internet. Let's get going. So throughout chapter 2, we've been studying logic and how logic applies very specifically to geometry and how it's going to help us in our studies. Now, today we're going to get into some actual theorems that you're probably a little bit familiar with, and you might be really familiar with a few of them, one of them being the Pythagorean Theorem. And here you can see a little introduction to that with the Pythagorean cat who will find the hypotenuse. However, before we go any further, let's establish ultimate and intermediate objectives. For chapter 2, our ultimate objectives have been to really identify that God is a logical God and that our Bible is filled with examples of how he used logic to make everything perfect and sound. Now, God has a logical plan for each and every one of you, and that means that it is our job to learn about, practice, and use this gift of critical thinking or this gift of logic, because it is something that's really special and specific to human beings. So our intermediate objectives for this last lesson in chapter 2 really have to do with 3 different geometry theorems. They're pretty well known, and I'll bet you've heard of them or at least used them before. And these theorems are the Pythagorean theorem, the triangle angle sum theorem, try to say that 3 times fast, and 2 different circle theorems. So this is chapter 2, lesson 6, some famous theorems of geometry. And we're on pages 65 through 67 in that, that textbook thing that we spent a lot of money on and that you drag back and forth. So get it open, get to page 65, get your Cornell notes and your pencils ready, and let's get going. So recall from our previous lessons that we studied this idea of undefined terms, our point, line, and plane. And that by kind of keeping these terms more general in their definitions and explanations, we can use them to keep from going in circles when we write definitions in geometry and even our postulates. Now, we can use those definitions and postulates to directly or indirectly prove that something is true. And when we've done that, then we've created a theorem. So really all of these steps all together are what we would call a deductive system. So here's a simple equation that you've probably seen before. A squared plus B squared equals C squared. So this equation actually has a much deeper meaning than it seems. And we're going to explore this in a little bit more detail, but really in a lot more detail later on in the book. So imagine that we have a square. It's 5 centimeters on each side. Now, if we wanted to find the area of the square, we could say 5 times 5 equals 25 centimeters squared. So what does this have to do exactly with the Pythagorean theorem? So let's use that same square from our previous example. And you know that you can work that 25 centimeters squared backward as well and find the square root, which is 5. That brings us back to that original side length. What if we added another square that's 16 centimeters squared? Of course, the square root of 16 is 4, which means that the sides of that square are 4 centimeters in length. And what about this little guy here? He's got an area, let's say, of 9 centimeters squared. But again, we can still find the square root of 9, which is 3. And so what we really have here is a triangle that we've created when we arrange these squares in a certain way. Do you see that triangle in the middle? Okay, now that you see the triangle, look for the right angle. So you can see that this makes a triangle with a right angle, where your 3 centimeter side is going to be your side A, your 4 centimeter side is going to be your side B, and your 5 centimeter side is going to be your side C. Now, if we go back to our original equation, a squared plus b squared equals c squared, we can start to get an idea of where the Pythagorean theorem and this well-known equation actually come from. It's pretty cool, isn't it? Now let's dig a little bit deeper in this example. So notice that if I take the area of my 2 smaller squares, my 9 centimeters squared and my 16 centimeters square, and I add them together, I actually get 25 centimeters squared. So let's break this down and work that idea backward. And let's think about taking the squares of all of those areas. In other words, 3 squared plus 4 squared equals 5 squared. Both of these equations that we're showing here are the exact same thing. We're just showing the numbers in 2 different ways. But essentially what we're seeing is that the squares of those 2 smaller squares equal the larger area, which brings us back to the beginning with a squared plus b squared equals c squared. Interesting. I'll let you kind of simmer on that idea of Pythagorean theorem and how right triangles have this special theorem where we can find the different legs by understanding the squares. And by the way, this also happens to be a Pythagorean triple, which all of this we will discuss later as we get into our sets 1 and 2. So the triangle angle sum theorem, which is not only fun to say, but fun to talk about, is another famous theorem that you've probably seen and used before, you just maybe haven't thought much about it. But basically, the idea is this. If we have a triangle like ABC, we know that the sums of those 3 angles equal 180 degrees. So this image that you see shows with a picture why this is true. Can you look at that picture and explain with words why you think this is true? Well, we'll talk more about this in class, but this will get you started. So the last 2 theorems discussed in lesson 6 are about circles, and you're probably really familiar with these concepts as well. But before we get into the theorems, I want to point out something about diameter and radius. Because isn't it true that if you know the diameter of a circle, you also know the radius? And if you know the radius, you also know the diameter. These concepts are going to be really important moving forward, and it is part of that idea of critical thinking. If you know one thing, you probably know something else about it as well. So keep these ideas in mind. But really, the bigger ideas here about the theorems are that if the diameter of a circle is d, its circumference is pi times d. The other theorem discussed in lesson 6 is if the radius of a circle is r, then its area is pi r squared. But really, if you know the radius of a circle, can't you also still find the circumference? And if you know the diameter of a circle, can't you still also find its area? The answer is absolutely, and that is one of the many things that we will be discussing in more detail the next time that we meet. But until then, get those notes done. Go back and read through lesson 6. Watch this video again if you need more support, and I will see you next time in class.